High above your head, far beyond the clouds, there is an invisible shield made of a faint blue gas. You can't see it, you can't feel it, and for most of history we didn't even know it was there. But without it, life on the surface of this planet would be scorched, blinded, and largely impossible. In the 20th century, we accidentally started destroying it, and then, in one of humanity's finest hours, we came together and saved it. This is the story of the ozone layer and the ozone hole, a genuine planetary emergency that we saw coming, understood, and actually fixed. In an age of environmental doom, it's the rare story with a happy ending. And it's one we urgently need to remember because it proves that when humanity decides to solve a global problem, we can. Let's start with what the ozone layer is and why it matters so much. Ozone is a molecule made of 3 oxygen atoms bonded together. The oxygen you breathe is 2 atoms, ozone is 3. It's rare, it's faintly blue, and high up in the stratosphere, a layer of atmosphere miles above the ground. It forms a thin, precious blanket around the entire planet. And that thin blanket does something extraordinary. It absorbs most of the sun's ultraviolet radiation before it can reach the ground. Ultraviolet light, UV, is the high-energy radiation that gives you sunburn. But that's the mild end. In large doses, UV is deeply damaging to living things. It breaks apart the molecules of life. UV radiation damages DNA, the genetic code inside every living cell. Too much of it causes skin cancer, cataracts, and immune damage in humans and animals, and it harms crops and the tiny plankton at the base of the ocean's food web. The ozone layer absorbs the worst of it, letting only a survivable trickle through. It is, quite literally, a shield that makes complex life on land possible. In fact, scientists think the ozone layer was essential to life emerging from the oceans onto land in the first place. For billions of years, life hid in the water, shielded from lethal UV. Only once the ozone layer built up could life venture onto the exposed surface and survive. That faint blue gas didn't just protect life on land, it helped make it possible at all. So the ozone layer is one of the quiet, invisible foundations of the living world. And here's the unsettling part. It's astonishingly thin and delicate. If you brought all the ozone in that layer down to the surface and compressed it to normal air pressure, it would form a shell only about 3 millimeters thick, thinner than a stack of a few coins. That wisp of gas is all that stands between us and a sterilizing blast of UV. A shield that thin, it turns out, can be damaged. And in the 20th century, we started manufacturing, by the millions of tons, a class of chemicals almost perfectly designed to destroy it, without having the faintest idea we were doing so. The story of how, and how we caught it in time, is one of the most important in all of environmental science. And the villains of the story began their lives as heroes. Because the chemicals that would nearly destroy the ozone layer were, when invented, celebrated as one of the great triumphs of modern chemistry, a miracle class of substances that made modern life safer and more comfortable. They were called chlorofluorocarbons. CFCs. CFCs were invented in the late 1920s and 1930s to solve a real deadly problem. The refrigerators and air conditioners of the era used toxic, flammable, dangerous gases, things like ammonia and sulfur dioxide, which sometimes leaked and killed people in their homes. Chemists were asked to find a safe alternative, and they succeeded brilliantly. CFCs seemed perfect. They were non-toxic, non-flammable, incredibly stable, and cheap to make. You could breathe them, spill them, heat them, nothing happened. They were the very picture of a safe chemical, so they were put to work everywhere, as the cooling fluid in every refrigerator and air conditioner, as the propellant in spray cans, as foaming agents, as industrial solvents. For decades, CFCs were a genuine boon. They made refrigeration safe and cheap, which transformed food storage and public health. They powered the spray cans and air conditioners of the modern age. Millions of tons were produced and used, all around the world. And that very stability, the property that made them so safe to use, was, unknown to anyone, the source of the catastrophe. Here's the trap. Because CFCs are so incredibly stable, so unreactive, nothing destroys them down here at the surface. They don't dissolve in rain, don't break down, don't react with anything. So once released, from a leaking fridge, a spent spray can, a CFC molecule just drifts upward. Slowly, over years, it rises through the atmosphere, indestructible, toward the stratosphere. Toward the ozone layer. And up there, high in the stratosphere, everything changes. Because up there, the CFC molecule is finally exposed to the full, unfiltered blast of the sun's ultraviolet radiation, the very radiation the ozone layer shields us from. And that intense UV does what nothing on the surface could. It breaks the stable CFC molecule apart. And when it breaks, it releases the one thing that is poison to ozone, a single atom of chlorine. That free chlorine atom is a catalyst of destruction. And catalyst is the terrifying word here, because a catalyst isn't used up. One chlorine atom attacks an ozone molecule, destroys it, and emerges intact, ready to destroy another. And another. and another, and another. A single chlorine atom can go on to destroy tens of thousands, perhaps 100,000, ozone molecules before it's finally removed. Let that sink in. Every CFC molecule you release carries a chlorine atom that, once it reaches the stratosphere, can wipe out 100,000 ozone molecules. And we were releasing millions of tons of CFCs. The math is horrifying. A slow-motion chemical assault on the planet's shield launched unknowingly from every fridge and spray can on Earth. But in the 1970s, nobody knew any of this. CFCs were still regarded as wonderfully safe and inert. It took two chemists doing basic curiosity-driven research to trace this invisible chain of destruction and to raise an alarm that almost nobody wanted to hear. In 1974, Mario Molina and Sherwood Rowland, chemists in California, worked out the whole terrible sequence. They calculated what happens to CFCs once released, the slow rise, the UV breakup, the release of chlorine, the catalytic destruction of ozone. And they realized, with growing horror, that the world's beloved miracle chemical was quietly destroying the planet's ultraviolet shield. Molina reportedly came home from the calculations shaken, telling his wife the work was going well, but it looks like the end of the world. They published their findings in the journal Nature in 1974, warning that continued CFC use could severely deplete the ozone layer with catastrophic consequences. It was a scientific bombshell. And the response was not gratitude. The reaction to Molina and Rowland's warning was, at first, skepticism, resistance, and outright hostility, especially from the industries that made and used CFCs. Billions of dollars and countless products depended on these chemicals. The idea that a spray can could damage the sky sounded, to many, absurd, even hysterical. The chemical industry pushed back hard. They questioned the science, funded counterarguments, and portrayed the warning as speculative alarmism. After all, this was a theoretical prediction about invisible chemistry happening miles overhead, with no direct proof yet that ozone was actually being destroyed. Why disrupt a hugely valuable industry over a theory? It's a pattern we've seen again and again, with tobacco, with acid rain, with climate change. When science delivers an inconvenient warning that threatens profits, the response is often to attack the science and delay action. The ozone story was an early, clear example of that playbook, and it worked for a while. Meaningful action stalled for years. There were some early moves. The United States, for instance, banned CFCs and most spray cans in the late 1970s, but globally, CFC production kept climbing. The chemicals were too useful, too profitable, and the threat too invisible and abstract for the world to take decisive action. The warning had been sounded, but the world hit the snooze button. And so, all through the late 1970s and early 1980s, we kept pumping CFCs into the atmosphere. Millions of tons of chlorine drifting slowly upward toward the ozone layer, while the scientific warning sat largely unheeded. The assault on the shield continued, invisible and unchecked. What was needed was undeniable proof, something that would shock the world awake. And it was coming from the most remote place on Earth. At the bottom of the world, in Antarctica, a small team of British scientists had been doing something wonderfully unglamorous, measuring the ozone overhead, day after day, year after year, from a remote research station called Halley. They'd been doing it since the 1950s, with instruments pointed at the sky, patiently recording the numbers. Boring, essential, long-term science. The team, Joe Farman, Brian Gardiner, and Jonathan Shanklin of the British Antarctic Survey, noticed something alarming in their springtime data in the early 1980s. Each Antarctic spring, the ozone directly above them was dropping. Not by a little, by a lot. And it was getting worse each year. At first, they could hardly believe their own instruments. They checked and rechecked, suspecting their aging instruments might be faulty. They brought in new equipment. The frightening drop was still there, and deepening. The springtime ozone over Antarctica was collapsing, falling by around 40% compared to earlier decades. A vast region of the shield was thinning dramatically, every spring. In 1985, they published their findings, and the world finally woke up. Their data revealed something that became one of the most famous graphs in environmental science, the story of the ozone over Halley, told in numbers stretching back to the 1950s. Look at what they saw. For decades, the 1950s, 60s, into the 70s, the springtime ozone reading held steady, right around 300 units. Stable, reliable, the shield was intact. And then, starting around 1980, the line falls off a cliff, plunging down and down, past the level scientists would come to call the threshold of an ozone hole, toward half its former value. A shield that had held for millennia was tearing open in a matter of years. The press called it the ozone hole. It wasn't literally a hole. The ozone wasn't gone entirely. But each Antarctic spring, a continent-sized region of severely depleted ozone, now opened up over the South Pole, a vast thinning of the shield where dangerous UV could pour through. It was a shocking, visceral image, a hole in the sky over an entire continent, and it made the abstract threat suddenly, terrifyingly real. And here's a remarkable, humbling twist. It turned out that NASA's satellites orbiting overhead had actually been measuring this ozone loss too, for years. But the readings were so extreme, so far below what anyone expected, that the data processing software had flagged them as errors, impossible values, probably instrument glitches, and set them aside for checking rather than sounding an alarm. So the satellites had seen the hole, but the low values were quietly held back as presumed mistakes because they were literally too alarming to be believed. It was the patient, ground-based measurements of a small British team at the bottom of the world that first raised the alarm. It pays to look closely at the anomalies. Now the world had undeniable proof, a gaping, growing hole in the planet's ultraviolet shield over an entire continent, worsening every year. And scientists quickly confirmed the cause was exactly what Molina and Rowland had warned about a decade earlier: chlorine from CFCs destroying ozone. The theory was now visible in the sky. But why Antarctica? Why did the hole appear there, at the bottom of the world, far from where most CFCs were actually used? The answer is a beautiful, chilling piece of atmospheric chemistry, and understanding it was key to grasping just how the shield was being torn open. The Antarctic winter is the coldest, darkest place on Earth. For months, the South Pole is plunged into total darkness, and a great swirling vortex of winds seals it off, trapping the frigid air. Up in the stratosphere, temperatures plunge so low that even in that bone-dry air, strange, wispy clouds form. Polar stratospheric clouds, made of ice crystals found almost nowhere else. And these clouds are the secret ingredient. On the surfaces of their ice crystals, chemistry happens that couldn't happen in open air. The chlorine that's been drifting up from CFCs gets converted on these cloud surfaces into a especially reactive, primed form, loaded and waiting, but held in check by the winter darkness because the final step needs sunlight. Then spring comes. The sun rises over Antarctica for the first time in months, and that returning sunlight triggers the loaded chlorine all at once, unleashing it to attack ozone in a furious catalytic frenzy. In a matter of weeks, the primed chlorine tears through the ozone above the pole, opening the hole. It's a perfect storm. Extreme cold, special clouds, trapped air, and the sudden return of the sun. That's why the hole appears over Antarctica each spring, even though the CFCs come from all over the world. The unique polar conditions concentrate and unleash the destruction there. It was a subtle bit of chemistry that took scientists real effort to unravel, but once they did, the picture was complete and damning. CFCs were tearing a hole in the sky, and the process was accelerating. And the implications were terrifying. If this could happen over Antarctica, could it happen elsewhere? Overpopulated regions? The ozone layer was thinning globally, not just at the poles. The Antarctic hole was just the most dramatic symptom. Left unchecked, the shield could degrade worldwide, meaning rising rates of skin cancer, cataracts, ecological damage, crop losses, a slow-motion catastrophe for all life on land. Scientists projected the future, and it was grim. One later estimate suggested that unchecked ozone depletion could have led to hundreds of millions of additional cases of skin cancer and devastating damage to ecosystems and agriculture by the middle of the 21st century. This wasn't a distant, abstract risk. It was a fast-moving threat to the habitability of the planet's surface. So here was humanity's situation in the mid-1980s. We had clear scientific proof of a growing hole in our planetary shield. We knew exactly what was causing it, a class of chemicals worth billions of dollars, woven into modern life, made by powerful industries, and we knew that stopping it would require the entire world to act together quickly against enormous economic pressure. It was the ultimate test. Would we rise to it? And this is where the story turns from alarm to something genuinely inspiring. Because the world did rise to it with a speed and unity that, in hindsight, seems almost miraculous. The shocking, visceral image of a hole in the sky had done what a decade of theoretical warnings couldn't. It galvanized public alarm and political will across the globe. In 1987, just 2 years after the hole was confirmed, the nations of the world came together and signed the Montreal Protocol, an international treaty to phase out the production of CFCs and other ozone-destroying chemicals. It was a landmark, a binding global agreement to give up a valuable, widely used technology for the sake of the planet's future. And it had teeth. The Montreal Protocol is often called the single most successful environmental treaty in history, and the reasons it worked are worth understanding, because they're a blueprint for solving global problems. First, the science was clear and the threat was visceral. a hole in the sky that could give your children cancer is easy to understand and impossible to ignore. The problem had a face. Second, there were alternatives. Chemists were able to develop substitute chemicals to replace CFCs in refrigerators, air conditioners, and spray cans. This mattered enormously. It meant giving up CFCs didn't mean giving up refrigeration or air conditioning, just switching to different chemicals. The economic pain was real but manageable, which made the politics possible. Third, the treaty was designed, well, it was binding, it was universal, it set firm phase-out schedules, and, crucially, it was strengthened over time as the science demanded, with later agreements accelerating the phase-out. And it included help for developing countries to make the switch. It was, in short, a masterclass in international cooperation. Every single country in the world eventually joined it, a first in the history of United Nations treaties. And so the world did what it seemed impossible. It identified a global threat, understood the science, developed alternatives, and coordinated nearly 200 nations to phase out the offending chemicals, all within a few years of confirming the danger. CFC production plummeted. Look at what happened once the world decided to act. There it is, the moment humanity changed course. CFC production, which had climbed relentlessly for decades, peaks around 1988 and then collapses, falling toward zero as the world phases them out. By the mid-2000s, production of these chemicals had essentially ended. We had turned off the tap. We had stopped pouring chlorine into the sky. It's one of the great environmental U-turns in history, but turning off the tap was only half the battle. Remember, CFCs are incredibly stable and long-lived. The chlorine already up there would keep destroying ozone for decades. The damage couldn't be undone overnight. Healing the shield would take not years, but many decades. A long, patient recovery, stretching across generations. The question was, would it actually work? Would the shield heal? For years, scientists watched and waited, tracking the ozone hole each Antarctic spring, looking for signs of recovery amid the natural year-to-year ups and downs. The hole kept forming, sometimes reaching record sizes even after the ban, because the chlorine was still up there, and the recovery would be slow and noisy. It took patience and faith in the science to trust that the turn had been made. But gradually, the evidence came in. The amount of ozone-destroying chlorine in the stratosphere began to decline, as the old CFCs slowly broke down and no new ones were added. And then, the signal everyone was hoping for, the ozone hole stopped growing, stabilized, and began slowly, unmistakably, to shrink. The shield was starting to heal. Today the science is clear. The ozone layer is recovering. It's on track to return to its healthy pre-1980 state over the coming decades, around the middle of this century for most of the world, and a bit later around 2066 for the Antarctic region specifically. The hole will heal. The shield will be whole again. Because we acted. Let's look at the arc of the hole itself, its rise, its terrible peak, and its slow, hard-won healing. It's one of the most hopeful graphs in all of environmental science. Look at that curve. The hole grows through the 1980s and 90s, reaching a monstrous peak around the year 2000, bigger than the entire continent of North America. And then, past the peak, it begins its slow, noisy, but unmistakable decline. That downward turn is one of the most important lines in environmental history. It's the site of a planetary wound beginning to close. Think about what that curve represents. It's the story of humanity identifying a threat to the entire planet and successfully reversing it through global cooperation. It is proof, hard, quantitative, undeniable proof, that when we understand a danger and choose to act together, we can heal even planetary-scale damage. We did it once. That changes everything about what we believe is possible. And the benefits are staggering. By phasing out CFCs, we're estimated to have prevented hundreds of millions of cases of skin cancer and tens of millions of cataract cases, protected ecosystems and fruit supplies, and preserved the habitability of the planet's surface. The Montreal Protocol quietly saved an incalculable amount of suffering. It's one of the greatest public health and environmental triumphs ever achieved, and most people barely know what happened. There's even a climate bonus. It turns out CFCs are also potent greenhouse gases, far more powerful, molecule for molecule, than carbon dioxide. So by banning them, the Montreal Protocol also prevented a significant amount of global warming, entirely as a side effect. It may be, accidentally, one of the most effective climate actions humanity has ever taken. A double gift we didn't even fully intend. So, the ozone story is, unambiguously, a success. A rare and precious example of humanity facing a global environmental crisis and actually solving it. And that success carries lessons that could not be more relevant to the great environmental challenge of our own time, climate change. The parallels are obvious and instructive. Both ozone depletion and climate change are global problems caused by invisible gases from human industry. Both were identified by scientists and initially met with denial and delay. Both require coordinated global action against powerful economic interests. The ozone story shows that this kind of problem is solvable. But it also shows why climate change is proving so much harder. Because look at why Montreal worked, and how climate differs. The ozone threat was visceral and easy to grasp. A hole in the sky, cancer for your kids. Climate change is more diffuse, gradual, and abstract. The ozone fix affected a handful of chemicals and industries. Climate change touches fossil fuels, which power our entire civilization. And CFCs had ready substitutes. Replacing all fossil fuels is a vastly bigger undertaking. So climate change is a bigger, harder version of the same kind of problem. But, and this is the crucial point, the ozone story proves the underlying approach can work. Global scientific consensus, international cooperation, phasing out harmful substances, developing alternatives, this playbook succeeded spectacularly once. It's not naive to think it could succeed again. We have literally done it before. That's why the ozone story matters so much right now. In a time of climate anxiety and environmental despair, it stands as concrete historical proof that humanity is capable of recognizing a planetary threat and coming together to fix it. It's an antidote to the poisonous idea that we're helpless, that nothing can be done, that global cooperation is impossible. We cooperated. It worked. The whole is healing, and it's a tribute to science working exactly as it should. Curiosity-driven chemists traced an invisible threat. Patient observers at the bottom of the world detected it. The global scientific community confirmed and explained it, and that science informed a political response that saved the shield. From a chalkboard calculation in 1974 to a healing planet today, that's science serving humanity at its very best. It's worth honoring the people who made it happen. Mario Molina and Sherwood Rowland, who sounded the alarm and endured years of hostility for it. Paul Crutzen, who illuminated the underlying atmospheric chemistry. In 1995, the three of them shared the Nobel Prize in Chemistry for this work, a rare case of a Nobel awarded, in part, for potentially saving the world. And the patient observers, Joe Farman, Brian Gardiner, and Jonathan Shanklin, whose unglamorous, long-term measurements at a remote Antarctic station caught the hole that satellites had dismissed. Their story is a reminder of how vital long-term monitoring is. There's a deep lesson in that. The hole was caught because someone was paying attention, persistently, over decades, to something that seemed routine. So much of protecting our world depends on that kind of patient vigilance, monitoring, measuring, keeping watch, so that we catch problems while there's still time to fix them. The unglamorous work of watching is some of the most important work there is. And there's a lesson about heeding warnings. Molina and Rowland raised the alarm in 1974, but meaningful global action didn't come until 1987. 13 years later, after a hole had actually torn open. Those were 13 years of continued damage that earlier action might have prevented. When credible scientists warn of a serious, invisible danger, the cost of delay can be enormous. That lesson echoes loudly today. But the ultimate message of the ozone story is hope. Earned, evidence-based hope. Not the naive hope that everything will magically be fine, but the grounded hope that comes from having actually done the hard thing once. We faced a genuine planetary emergency and we solved it. The sky was breaking, and we fixed it. That is a true story, and it should give us courage. So the next time you feel despair about the state of the planet, remember the ozone layer. Remember that high above you, a shield that we were tearing apart is now healing, because humanity chose to act. Remember that nearly 200 nations set aside their differences and their short-term interests to protect the future of all life on Earth. And remember that it worked. Every day, that invisible blue shield high above absorbs the sun's ultraviolet radiation, protecting your skin, your eyes, your DNA, the crops in the fields, the plankton in the seas. We almost destroyed it without even knowing. And then we caught ourselves, understood what we were doing, and stopped. The shield endures because science warned us and humanity listened. It's a story worth telling loudly and often, because it's the proof of concept for everything else we need to do. It says, global environmental problems are solvable. Science can guide us. Nations can cooperate. Powerful industries can be reformed, and planetary wounds can heal. We are not helpless. We have the tools, the knowledge, and when we choose to use it, the will. The ozone layer nearly vanished, a slow-motion catastrophe we launched from every fridge and spray can on Earth. and then it came back, because a few curious scientists followed the chemistry, a few patient observers caught the damage, and the whole world, for once, did the right thing in time. If that's not a reason for hope, nothing is. So look up, and know that the sky is healing. Know that we did that, deliberately, cooperatively, guided by science, and carry that knowledge into every other challenge we face. Because the ozone story doesn't just tell us that we saved the shield, it tells us who we can be when we decide to protect our only home. That is the story of the air that vanished and came back, a near catastrophe, a scientific triumph, and the single best evidence we have that humanity can rise to a planetary emergency. The hole in the sky is closing, and we closed it. It's the environmental success story we should all know by heart, not to make us complacent, but to make us brave. We've done the impossible thing once, that means we can do it again. The sky is proof. Let's gather what this remarkable story leaves us. First, the science. A thin, invisible layer of ozone high above us shields all surface life from the sun's damaging ultraviolet radiation, and it's delicate enough that a class of human-made chemicals drifting up over decades could tear it open. Second, the crisis. CFCs, celebrated as safe miracle chemicals, released chlorine into the stratosphere where a single atom could destroy 100,000 ozone molecules, opening a continent-sized hole in the shield over Antarctica each spring. We caused a planetary emergency without even realizing it. Third, the response, warned by curious scientists, alerted by patient observers, and shocked awake by the image of a hole in the sky. The world came together in the Montreal Protocol of 1987, every nation on Earth, to phase out the chemicals and save the shield. It's the most successful environmental treaty in history. And fourth, the healing. With the tap turned off, the ozone layer is recovering, on track to be whole again by mid-century. The hole is shrinking. The wound is closing. We faced a planetary threat and reversed it. The clearest proof we have that humanity can solve global environmental problems when we choose to. That last point is the one to carry with you. In an age heavy with environmental fear, the ozone story is a beacon. It says, with the authority of hard data and lived history, we are not doomed and we are not helpless. We identified an invisible global industrial threat to the whole planet and we fixed it. The sky is healing because of choices we made, and it lights the way for the challenges ahead. Climate change is bigger and harder, but it's the same kind of problem. And the ozone story hands us the playbook: trust the science, develop alternatives, cooperate globally, act before it's too late, and don't let the merchants of doubt delay us. We've run this play before, and won. We can run it again. So honor the people who made it possible. The chemists who followed their curiosity into an inconvenient truth and endured hostility for it. The observers who watched the sky patiently for decades. The diplomats and citizens who turned science into action. They saved a piece of the world quietly, and most of us never even knew. Their example is a gift, and take from it a habit of grounded hope. Not the passive hope that says someone else will fix it, but the active hope that says problems can be solved, I've seen it done, so let's get to work. There's also a quieter lesson about the invisible foundations of our world. We lived for millennia under a shield we couldn't see and didn't know was there, until we nearly destroyed it. It makes you wonder what other invisible systems quietly sustain us, unnoticed and unappreciated, that we do well to understand and protect before we damage them. The ozone layer taught us humility about our power to affect the whole planet, for ill and for good. We are now a force of nature, capable of altering the atmosphere of an entire world. That's a terrifying power. But the ozone story shows it can be a healing power too, if we wield it with wisdom, guided by science and a sense of shared responsibility for our only home. So look up. The sky above you is not empty. It holds an invisible shield of faint blue gas, 3 millimeters thick if you squeezed it. That makes your life possible. We nearly broke it. We caught ourselves, and now it's healing. A little more every year thanks to a decision the whole world made together back in 1987. Every sunny day you enjoy without harm, every unblemished harvest, every healthy ocean owes something to that shield and to the people who saved it. It's a debt we rarely think about, paid to scientists and diplomats decades ago whose foresight protects us still. The least we can do is remember and be inspired. And the very best way to honor the ozone victory is to apply its lessons. To face the environmental challenges of our own time with the same clear-eyed science, the same global cooperation, the same refusal to let short-term interests override the future. The ozone story isn't just history. It's an instruction manual for saving the world, and it's been proven to work. Because if a few curious chemists and patient observers could catch an invisible threat to the entire planet and rally the whole world to fix it, then the problems we face today, however daunting, are not beyond us either. The ozone layer is the proof, hanging right there in the sky above your head, healing a little more with every passing year. So the next time someone tells you global problems are unsolvable, that people can never cooperate, that we're helpless in the face of environmental threats, tell them about the ozone layer. Tell them about the hole we tore in the sky and how we came together and closed it. Tell them the sky itself is healing. And tell them we did that. From a miracle chemical to a hole in the sky to a healing shield. That's the arc of the ozone story. A cautionary tale about unintended consequences and a triumphant tale about science, cooperation, and hope. One of the most important stories humanity has to tell about itself, and one of the most encouraging. It reminds us that we are capable of foresight, of sacrifice for the common good, of setting aside division to protect what we all depend on. Those capacities are real. We've exercised them before on a planetary scale, and it worked. Whatever comes next, we carry that proven capability with us. The ozone story is, at heart, a story about the better angels of our nature, and how, sometimes, they win. We began with an invisible shield we didn't know we had, and a threat we couldn't see. We end with a healing sky and a proven path forward. In between is one of the great success stories of the modern age, the time we nearly broke the sky, and then, together, fixed it. That's the story of the air that vanished, and came back. The ozone layer, the hole we tore in it, and the remarkable, hopeful way the whole world came together to heal our fragile, invisible, life-giving shield. Stay curious about the invisible systems that keep you alive, the shields and cycles and balances you never see, but that make everything possible. Understanding them is the first step to protecting them. The ozone layer was invisible until we nearly lost it. Let's not wait that long with the next one. And stay curious about what humanity can achieve when we work together. The ozone victory is proof that our cooperative, problem-solving power is real and formidable. In a world that often feels divided and doomed, that's a truth worth holding on to and acting on. So the next time you step outside under a clear sky, look up and remember, we once tore a hole in the invisible shield that keeps everything alive. And then, for the first and only time in history, the entire world stopped and fixed it. The sky above you is proof that we can solve the impossible when we decide to. If this gave you a little hope, do two quick things. Subscribe so you don't miss the next story we bring back to life. And tell me in the comments, what global problem do you actually believe we can solve? Then watch this next, the mind-bending story of how every single atom in your body was forged inside a dying, exploding star. It's right here. I'll see you there.